Learning objectives.
At the end of this topic, you will be able to understand the method of evaluating a quadratic equation by factorization method, solving problems using factorization method, find the solution of a quadratic equation by completing the square, solve problems based on solution of a quadratic equation by completing the square, determine types of roots of quadratic equations based on the value of discriminants. Now we are able to identify the given equation is a quadratic equation or not. Let's find the solution of quadratic equation by factorization. Consider quadratic equation 2x squared minus 3x plus 1 equal to 0. By replacing x by 1, we get 2 into 1 square minus 3 into 1 plus 1 is equal to 0. Hence, 1 is a root of the quadratic equation 2x squared minus 3x plus 1 equal to 0. This also means that 1 is a 0 of the quadratic polynomial 2x squared minus 3x plus 1 equal to 0. In general, a real number alpha is called a root of the quadratic equation ax squared plus bx plus c equal to 0, a not equal to 0, if a alpha square plus b alpha plus c equal to 0. We also say that x equal to alpha is a solution of the quadratic equation, or that alpha satisfies the quadratic equation. Note: zeros of the quadratic polynomial ax squared plus bx plus c and the roots of the quadratic equation ax squared plus bx plus c is equal to 0 are the same. We've already learned how to factorize a quadratic polynomial by splitting the term. Now we will extend this to quadratic equations. In quadratic factorization, using splitting of the middle term, which is x term, is the sum of the two factors and product equal to the last term. To factor the form ax squared plus bx plus c, factor 6x squared plus 19x plus 10. 1. Find the product of the first and the last term. A into c. 6 into 10, that's equal to 60. 2. Find the factors of 60 in such a way that addition or subtraction of that factor is the middle term. 19 into splitting of the middle term. 15 into 4, that's equal to 60. And 15 plus 4 is equal to 19. 3. Write the center term using the sum of the two new factors, including the proper signs. 6x squared plus 15x plus 4x plus 10. 4. Group the terms to form pairs. The first two terms and the last two terms. Factor each pair by finding the common factors. 3x into 2x plus 5 plus 2 into 2x plus 5. Factor out the shared common binomial parenthesis 3x plus 2 into 2x plus 5. We've already learned how to factorize a quadratic polynomial by splitting the term. Now we will extend this to quadratic equations. Let's consider some equations. Find the factors of 6x squared minus 13x plus 6. 6x squared minus 13x plus 6 is equation 1. AC, A dot C is equal to product of 6 and 6, that's equal to 36. Factors of 36 equal to 2, 18, 3, 12, 4, 9. Only the factors 4, 9 give 13. 4 plus 9. For minus 13, both the factors have negative sign. Minus 4 minus 9. That's equal to minus 13. Equation 1. 6x squared minus 4x minus 9x plus 6. That's equal to 2x into 3x minus 2 minus 3 into 3x minus 2. That's equal to 3x minus 2 into 2x minus 3. Other factors. Let's move to another example. Find the value of x in 12x squared minus 15 equal to minus 11x. Solution: 12x squared minus 15 is equal to minus 11x. 12x squared minus 15 plus 11x is equal to 0. Add plus 11x. 12x squared plus 11x minus 15 is equal to 0. 12x squared plus 20x minus 9x minus 15 is equal to 0. 4x into 3x plus 5 minus 3 into 3x plus 5 is equal to 0. 3x plus 5 into 4x minus 3 is equal to 0. 3x plus 5 is equal to 0 or 4x minus 3 is equal to 0. 3x is equal to minus 5 or 4x is equal to 3. X is equal to minus 5 by 3 or x is equal to 3 by 4. Solution is minus 5 by 3, comma 3 by 4. Let's move to another example. Find the factors of 3x squared minus 2x minus 1. Solution: 3x squared minus 2x minus 1 equal to 0. 3x squared minus 3x plus x minus 1 equal to 0. 3x into x minus 1 plus x minus 1 equal to 0. X minus 1 into 3x plus 1 equal to 0. That means x is equal to 1 and x is equal to minus 1 by 3. We can complete the square to solve a quadratic equation. But a general quadratic equation can have a coefficient of a in front of x squared. Ax squared plus bx plus c equal to 0. But that is easy to deal with. Just divide the whole equation by a first, then carry on. X squared plus b by ax plus c by a is equal to 0. Now we can solve a quadratic equation in 5 steps. Step 1. Divide all terms by a, the coefficient of x squared. Step 2. Move the number term c by a to the right side of the equation. Step 3. Complete the square on the left side of the equation and balance this by adding the same value to the right side of the equation. Step 4. We now have something that looks like x plus b the whole square is equal to q, which can be solved rather easily. Take the square root on both sides of the equation. Step 5. Subtract the number that remains on the left side of the equation to find x. Let's move to example 1. Solve x squared plus 4x plus 1 equal to 0. Step 1 can be skipped in this example since the coefficient of x squared is 1. Step 2. Move the number term to the right side of the equation. X squared plus 4x is equal to minus 1. Step 3. Complete the square on the left side of the equation and balance this by adding the same number to the right side of the equation. b by 2 the whole square is equal to 4 by 2 the whole square is equal to 2 square, that's equal to 4. X squared plus 4x plus 4 is equal to minus 1 plus 4. X plus 2 the whole square is equal to 3. Step 4. Take the square root on both sides of the equation. X plus 2 is equal to plus or minus root 3. That's equal to plus or minus 1.73 to 2 decimals. Step 5. Subtract 2 from both sides. X is equal to plus or minus 1.73 minus 2. That's equal to minus 3.73 or minus 0.27. Let's move to another example. Solve 5x squared minus 4x minus 2 is equal to 0. Step 1. Divide all terms by 5. X squared minus 0.8x minus 0.4 is equal to 0. Step 2. Move the number terms to the right side of the equation. X squared minus 0.8x is equal to 0.4. Step 3. Complete the square on the left side of the equation and balance this by adding the same number to the right side of the equation. b by 2 the whole square is equal to 0.8 by 2 the whole square. That's equal to 0.4 square is equal to 0.16. X squared minus 0.8x plus 0.16 is equal to 0.4 plus 0.16. X minus 0.4 the whole square is equal to 0.56. Step 4. Take the square root on both sides of the equation. X minus 0.4 is equal to plus or minus root 0.56. That's equal to plus or minus 0.748 to 3 decimals. Step 5. Subtract minus 0.4 from both sides. In other words, add 0.4. X is equal to plus or minus 0.748 plus 0.4. That's equal to minus 0.348 or 1.148. Let's move to another example. X squared minus 16 is equal to 0. X squared minus 4 square is equal to 0. x plus 4 into x minus 4 is equal to 0. Hence, x plus 4 is equal to 0 or x minus 4 is equal to 0. Therefore, x is equal to plus 4 or x is equal to minus 4. X square minus 36 is equal to 0. X square minus 6 square is equal to 0. X plus 6 into x minus 6 is equal to 0. Hence, x plus 6 is equal to 0 or x minus 6 is equal to 0. Therefore, x is equal to plus 6, x is equal to minus 6. Use the quadratic formula to solve x square minus 4x minus 8 is equal to 0. Looking at the coefficients, we get a is equal to 1, b is equal to minus 4, c is equal to minus 8. Using them into the formula and simplify, we get solve x square plus 3x minus 4 is equal to 0. Using a equal to 1, b equal to 3 and c equal to minus 4. We have seen that the roots of the equation ax square plus bx plus c is equal to 0 are given on the screen. If b square minus 4ac is greater than 0, there are two distinct roots. If b square minus 4ac is equal to 0, then value of x is as shown. Therefore, we say that the quadratic equation ax square plus bx plus c equal to 0 has two equal real roots in this case. If b square minus 4ac is less than 0, then there is no real number whose square is b square minus 4ac. Hence, there are no real roots for this given quadratic equation in this case. Since b square minus 4ac determines whether the quadratic equation ax square plus bx plus c equal to 0 has real roots or not, b square minus 4ac is called the discriminant of this quadratic equation. So, a quadratic equation ax square plus bx plus c equal to 0 has 1. Two distinct real roots if b square minus 4ac is greater than 0. 2. Two equal real roots if b square minus 4ac is equal to 0. 3. No real roots if b square minus 4ac is less than 0. Summary. Let's summarize the topic. A real number alpha is said to be a root of the quadratic equation ax square plus bx plus c is equal to 0 if a alpha square plus b alpha plus c is equal to 0. The zeros of the quadratic polynomial ax square plus bx plus c and the roots of the quadratic equation ax square plus bx plus c equal to 0 are the same. If we can factorize ax square plus bx plus c, a not equal to 0 into a product of two linear factors, then the roots of the quadratic equation ax square plus bx plus c equal to 0 can be found by equating each factor to 0. A quadratic equation can also be solved by the method of completing the square. A quadratic equation ax square plus bx plus c equal to 0 has two distinct real roots if b square minus 4ac is greater than 0. Two equal roots, that is coincident roots, if b square minus 4ac is equal to 0, and no real roots if b square minus 4ac is less than 0.